you know what symmetry is?
Yeah.
What does this have symmetry to?
You can draw a line in the middle of it and like it's same on both sides.
Yes. So in other words, this has symmetry right here. Does it have symmetry here?
No.
No. Does it have symmetry here?
No.
No. Symmetry means if you were to take, see this, it's an imaginary line and it goes through the vertex. If you were to draw an imaginary line called the axis of symmetry, that is the line that this graph has symmetry to. So however many points or units the graph is away from that axis, you're going to sure find that other point the other direction. Okay? So in other words, if I were to fold or cut this function along this line, in any ways, what's the name of this line? It has a name. X equals 4. The line, this graph has symmetry to the line x equals 4. Does everybody understand that?
Mm-hmm.
I could draw something, I could draw a parabola. Right here's a parabola. This parabola, this quadratic equation function, has symmetry to the line x equals 3. Here's another absolute value. This one had symmetry to the line x equals -5. Does everyone see that? I could draw something like this. This is not a function. Why? Because it doesn't pass the vertical line test. But it does have symmetry. What does it have symmetry to? It has symmetry to the line y equals whatever this line is. Actually, here's 0. 2, 3, 4, 5, 6, 7, 8, if I count it right. Y equals -8. Okay? What we're doing in this section is we are going to talk about symmetry to 3 special things. I'm going to show you. I'm going to show you. I'm going to show you. Hang on. Hold on to your question. It's a good one. All right. The 3 things we're going to test for symmetry are to the y-axis. I'm not looking at, does this have symmetry to the line x equals 4? I'm asking you specifically for the y-axis right here. Okay? So in other words, if you can take your graph, and it may not be a function. That is not a function. That's an ellipse. That's an ellipse. An ellipse is a distorted circle. It's not, doesn't have a radius that's the same. Okay? But this is an ellipse. If you can take your picture and fold it on the y-axis, this main axis right here, if you folded this side over or that side to this side, if they match, identical, then yes, they are, this is symmetrical to the y-axis. Does that make sense?
Yes.
All right, now, so we can all look at a graph and in our mind fold it over and see if it matches and say yes or no, right? All right, now I want to give you another test. I want you to look at this ordered pair. This is 6, 3, right? Can you guys see it on yours? Mine's small there. Okay, this is 6, 3, and this ordered pair is -6, 3. I'm going to name a few other points. What if I call this 1, 7? Then guess what? -1, 7 will also be on that picture. I'm going to call this, let's say, 3, 5. I'm making this up. What do you think this point's going to be? -3, 5. Do you see what's happening here? Can anyone articulate what is going on? When a graph has symmetry to the y-axis, what do you notice happening about the ordered pairs?
The x value.
And they have it right here. So, if xy is on the graph, then negative xy will be on the graph. So you could take your graph and test it, because sometimes they get really tricky. What you'll do is find a point. Just pick a point. If 3, 5 is on the graph, then what other point should you find?
Negative 3, 5.
Negative 3, 5. What if negative 6, 4 is on the graph?
6, 4 on the other side.
Okay. So what are you doing? This is what you're doing. A graph is symmetric with respect to the y-axis if, whenever xy is on the graph, so is negative xy. So you're just changing the x value. So that's if you were to look at a picture. But look at this. I'm asking you if that equation is symmetrical to the y-axis. Do you have a picture in front of you? Do you have a picture?
No.
Do you see a picture right there?
No.
All right, so now, here's 2 things you can do. You can get a picture of it. How can you get a picture of this?
Graphing calculator.
Yep. So here it is. How nice I have it. I'm going to graph it. That's what I get. Now, I'm going to think about this. That picture's kind of squishy. How do I know? It looks symmetrical.
Couldn't you use the
It
table?
really, say it again.
Use the table.
Use the table. You're going to hit second table. And what are you going to want to look for? Play around with your numbers. Remember what I said? If negative 2, negative 1 is on the graph, then 2, negative 1 should be. See how 339 is? Negative 339, and so is 339. So what did we do? We're changing the x values, positive, negative. For every ordered pair that's there, if you switch the x value to make them opposite, then other ordered pairs there. So there's your picture. So if we have access to a graphing calculator, we can graph them and check out the table. Got it? Now, algebraically, what are you going to do? The test goes like this. If you want to algebraically prove that a graph has symmetry to the y-axis, well, if the x values are all, if the opposite is there, that's what you're doing. You're going to replace, every time you see an x, you're going to put a negative x. And you're going to perform your algebraic magic on it. You're going to redo the problem. Sometimes you're going to have to multiply the whole equation by negative 1. If you can get the equation back to its original identical state, then it has symmetry to the y-axis. So this is what you do. That's what you do. And I typed right here for you in my words to algebraically determine whether or not a graph has symmetry to the y-axis. Simply replace x for negative x and simplify it. If you get the same equation, then yes, it does have symmetry to the y-axis. So this is what you do. So what do you think? Y-axis, you replace every time you see an x, you're going to put in the opposite of it. So here we go. You've got y equals, here's an x, here's another x, now let's clean this, simplify it. How would you simplify this? What is a negative x multiplied 4 times? What is a negative x squared? Positive x. Did we get the original problem?
Yes.
Yes. So yes, this has symmetry to the y-axis. Sometimes it works, sometimes it doesn't. Yep. The next one. And by the way, if you go back to the y-axis symmetry, There's another, if a graph does have symmetry to the y-axis, this has another name. It is an even function. So y-axis symmetry and even function are interchangeable. So if someone says, is this an even function? They're asking you, does that have symmetry to the y-axis? And you would have to perform the same test. So remember, y-axis symmetry is an even function, okay? So it has two names. Next, look at this one. X-axis symmetry. Here's your x-axis. I bet you guys could figure out, look at this ordered pair. What's the name of this ordered pair? What is that point? It says 2 root 5. It's hard to read. Can you read that point?
2 negative root 5.
I'm going to make this point up. This is 1, we'll do 1, 2. Guess what this one's going to be?
1 negative 2.
I'm going to call this negative 3, 1. Okay. Now what does x-axis symmetry mean? It means that if you were to fold this thing along the x-axis, they would match up. It also means that for every ordered pair that you have, what stays the same and what changes? Can you tell me? X stays the same and Y changes. Very good. So, and that's all explained there. If you were looking at a graph and you wanted to see if it has symmetry to the x-axis, all you do is look at your points and see that the y value is reversed. If negative 3, 5 is there, negative 3, negative 5 better be on that graph. Do a few of those test points.